My name is Niklas. I'm from a town called Gävle. And in Gävle, we have Gävlebocken, the world's largest straw goat. Someone always sets it on fire. Don't set it on fire, it's illegal. But it's kind of awesome, though. One year, it got eaten by birds. This is my dog. Her name is Hot Dog. Here's one more picture of my dog. I'm making a game about her. Let's look at a video from the game. This one. Let's do a little pause. You see the sequencer here. There's a kick drum and a kick drum. This kick drum makes these things go back and forth, right? And then there's a snare drum, and the blue one that changes other things in the level, and the green one also changes other things in the level. Is the volume good? Is it too loud or too silent? Okay, super. This is the game's main mechanic. When the dog uses the sequencer, the player gets control over the drum machine and can put in their own music in there. So now you will be able to see the player moving around the cursor, which affects the levels. And now the player is ready to solve the challenge with the music they just created. And the two things you should pay attention to is note that a lot of the instruments are adapting to the music that the player created. Like the bass line and the hi-hat is completely generated from what the player did there. And also note the build-up. The further in the player gets in the challenge, the more tension the music builds. And now the music calms down because you beat the challenge. So that's the game I'm currently creating. So my talk is named The Music Algorithm Smorgasbord, because I'm Swedish, and in Sweden it's called Smorgasbord. So I think the word is just remove the dots over the letters and keep exactly everything the same. This is my software. So let's look at the algorithms. The first algorithm I want to show is a very, very simple one. It should hang out over... Oh yeah, it's this one. So this is a sampler. This just plays musical samples. Currently it's reading through a chain of devices, but I'm gonna bypass a few of them and type in -1 here. Wait, that's the wrong one. I think I was supposed to type it in here. So now I'm reading directly from this device. This device is called a delay chain. This device is basically... I think I have to explain one thing before I explain this. This software is driven by a single value, which is called the step. The step is shown up here. If I start it, you can see this value, just this number going up. And that value is driving everything, like all the algorithms. This particular device, it plays a note, and then it waits a number of steps. And then it does it again And every time it plays a note, it asks the module, how many steps should I wait until the next one? So let's say I put in the number 4 here. Then we get this. Wait, okay, let me just disable that one first. Yeah, you can hear it every 4 steps. Very simple. And this is controls the velocity, this little thing I put in here. So it's like, sometimes it hits it harder than other times. That was the first device. Let's move over to the harmonizer. So I should put this one back to like that. So now I'm routing this through a device that I will explain later, but this doesn't do anything right now. But I send it to the harmonizer, which is, it adds additional things after. I originally designed it to, you give it one note and instead it plays a chord, but then I added the ability to delay each note. So now, based on the velocity, it adds extra notes. And you get that sort of thing, right? And let's put this, the original thing I had. I didn't play it every 4th step originally, but I think I used, yeah, I'll just paste it back through the clipboard. I think I used every 3rd step with a 0.1% chance of adding an extra step. And you get this. It doesn't sound good, but it will sound good when I add it together with other stuff. But we will get to that later. First, let me go back to the arpeggiator. There you are. So the arpeggiator is a very classic sort of synth thing. A lot of synths has it. You play a lot of notes at the same time, but instead of it playing those notes at the same time, it cycles between them. So like you hold like a C major chord and it goes pop, 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 like that, right? So if I enable that one, currently it's doing this. But attached to it is the Rainbow device. This one I wrote specifically for this conference. What this is, it takes this input array and rearranges it freely. So right now, you can see the sequence going up here, right? And this is what you're listening to now, like this going up. But now I start sorting it in real time while it's playing. And now it's going down. But it has this interesting transition thing going on between these 2 stages. A way I use this in my current game is that every time you go through a door, the sequence is sorted, but only a little. So you have this kind of door melody, but every time you go through a door, the melody has changed a bit since the last time you went through it. So that's a fun one. And now we are gonna go into esoteric territory here. Because now we are going into the democratic beat. And this was an idea, I had a very silly idea. I ran a series of Twitter polls back before Elon took it over and it turned evil. But back then I was still on Twitter and I asked, okay, let's make a drum pattern together. Step 1. And then I listed instruments, and then people got to vote: silence, kick, snare, or let's see. This one was kick, silence, tom, and snare, and the other poll was silence, closed hi-hat, open hi-hat, and a clap. And I did change the instruments a little bit in this song. I don't map it to the same instruments, but the data is based on 32 polls, where I took the averaged, and then I just, I put the averaged in like this. So it's based on this Twitter data here. And then I punched in these different weights, and then with these different weights, then this sounds like this. Which is kind of lucky, right? Like, who would have thought that you could just take random replies from Twitter and actually that would be the result? Given, of course, I put in these specific weights here. And then let's move on to the train stop device. It's also a device I wrote for this conference, although I did write it for... I did a practice run of this talk at a a university, Sonic College, I believe, in Denmark. I think it's a university. Anyway, I was holding this a mini version of this talk, and on the train there, I got stuck, and 3 hours because the train in front of us had been in an accident, and suddenly I was stopped, just sitting there thinking, what should I do now? Stuck in a train. Let's make an algorithm about being stuck in train traffic. It's the logical thing to do, right? That's this one, the train stop device. So let's... I just want to increase a specific value here so I can demo it better. Let's do this one, 64, and that one. So you see, these are the democratic beat things, the ones that generated the drums you just heard, but they are routed through the train stop devices, and these are activated with these two buttons here. And what the train stop device does is that it intercepts the messages that are meant to trigger the nodes and caches them, but it doesn't pass them to the device after. It just holds on to them while the train stop is active. And then after, when you release the train stop, when the trains are allowed to go again, they play really fast just to catch up. So now we hear it normally. And now I stop the trains. And now I resume them. Again, it sounds weird, but it's going to make way more context when I play the instruments together. But let's leave that one for now, and let's move on to the railway sequencer, which is another device inspired by trains. Which is that's the one, yeah. Because this is a little bit hard to parse, I'm gonna try to make this a little bit more understandable. Paint, nice. Let's imagine a train track like this, right? And at the end of the train track is a portal, and then that portal is connected to this portal. So the train goes down, hits the portal, and starts from the beginning. And let's say this circle is a kick, and then here's a kick, and then this is a snare, right? Wait, I'm not used to changing color after I draw it. And okay, so kick, kick, snare. So you imagine the train going like boop, 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 boop. Makes sense, right? But that's just a classic step sequencer. It's a very common thing. But then you imagine another rail track next to it. Also with a portal at the beginning and an end. Let's say this one has like 3 snares here. So this one goes silence, 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 and silence, silence, and so on. But this device has a property which is every time it hits a note, that note also includes a chance to take a switch to the next track instead. So it's kind of looping across these different sequences, but on every note, it's just randomly gonna jump to another track. And it can be a random track, it can be the next track in the same sequence. It's up to whatever values you put in. It sounds like this. And you can see it reading from here. So every time it jumps to the right, it's because it changed the track. For fun, let's just show what the instruments were you just heard. When I needed the instruments, I went out on a trip with my dog. I bonked this. I had a microphone with me. And then I found this, and I bonked that too. And I bonked my toaster. And I bonked a door frame in my bathroom also. So that's actually the sounds you're hearing. And that's the railway sequencer. Let's move on. Then we have the... says I should say show the Desire one next. Come on. Really? I actually don't think that was my fault. I don't know what happened there. Anyway, let's go manual and let's look for... oh, this is it. That's the one. Yes. This device is based on, it has 5 different notes it wants to play. Each note has its own desire to play. The longer it has been since the note has been playing, the more it really wants to play. And every time it plays, it calms down a little bit and wants to wait a little bit until the next time. But I have these phases where I build up, each of the devices build up more like a stronger desire. I need to play my note now. And then they have periods when they want to play less. It's a little bit tricky to explain, so I will enable the debug device, and which is going to show the desires these notes have. And hopefully it's going to make sense if you look at what it says. Oh, I have to play the instrument too. That's an advantage. So these bars are the desire to trigger. And different configurations has different behaviors also. Wait. Oh, I don't use that one right now. I use this one. Oh, this one is nice. Then let's show the reflector, which looks like this right now. This one will take a little bit of explaining. 2 cursors will move around. You will see the 2 cursors. Every time a cursor collides with one of the squares, it reflects onto another direction and also plays a sound. However, if it collides with a white one, it will always reflect every time. But if it collides with one that has a color between, it has a chance of reflecting depending on the intensity of the colors. Sounds like this. Oh. They have this tendency to be silent because they're just looping around here for a while. But sooner or later they can get bounced in again. So you end up with this kind of nice natural pauses, and yeah, now they're going in again. Yeah, that's the reflector. And finally, we have the tweet randomizer, which is this device. Looks very unassuming. And it has all of these different algorithms. So a problem in computing, of course, is generating random, like truly random numbers, because it's a mathematical process. You cannot actually generate true randomness. Does true randomness even exist? Who knows? Maybe we could sample quantum noise, I don't know. But I wanted to have something really random, not just random as a computer, but like truly random. So I went to the most confusing thing in the entire world, the human brain. And I asked on Twitter, hey, can you give me random sequences? Just come up with a random sequence in your head and tell it to me. And I put it together, right? Let's have a look of the data. Yeah, here are a lot of different sequences. Let's disable word wrap. Like, look at this, truly random. 2, 3, 5, 2, 6, 6, 3. Yeah, this one, 7, 7, 7, 7, 7, 7, 7, and a 4 at the end. I also think somewhere here there's like a single negative number. Let's see if we can find it. Yeah, someone just put in minus 63, and no one else realized they could put in negative numbers. So yeah, back to the music software, and let's. So this one sounds like this. Wait, I forgot to disable this one for now. No, I'm not finding it. Oh, there it is. Okay. Or I have to press the button also. This is such a random sequence. But let's try a different one. Let's try this one, maybe. You can see it has a different character, because humans come up with more interesting random numbers than computers do. Let's see what this is. Actually, let's listen to the 7777. That's Porter. And it does change a little bit, and that's because of the note selection thing I'm using has a bunch of other slightly random things built into it. But it's still, you can hear it playing very similar pitches all the time, that algorithm. And I believe that's all the algorithms I had to show, so I think next I should play it all together, right? I'll do a little performance, what this actually sounds like. And I'd reload it so it's without my changes. And first I will set the scene. This takes place in this level, which I'm designing right now. It's a very rainy sort of place. And it has these kind of teleporting things that teleport the dog in sync with the music. So that's the mood I'm going for. And let's try it out. Yeah. So that's what it sounds like.
Thank you very much. I think that was the first time we basically had a concert at the EPC. Okay, some questions. What does the awkward parameter do that I saw in one of your notes?
That I actually offered to have an entire talk about the note selection system, but that would have taken 20 minutes. But the short version is, so every note, every musical scale is defined by a lot of different values. One of the most important units is called awkward, which is loosely defined as if I were playing the bass chord in the current mode and scale, how awkward would it be to only jazz on this particular note? If it would be really awkward to jazz on it, then it gets a really high value. And like the bass note, the root note in the scale always gets an awkward of 0. And it can be very good for an algorithm to not pick like a degree in a scale, but actually pick the note according to how awkward it is instead.
Thank you. Okay. Mm-hmm. Just super impressive presentation. So I'm really curious how you arrived at the user interface or the UX of the program that you're using.
I think I wanted a kind of a modular approach, but I was, I think I don't like dragging modules around on these open spaces and trying to figure out where all the cables go, and it gets really confusing. I figure if I put it on a grid, I can like drag things. I can just cut it out and paste it in like this. And I think I find it easier to work with the modules on just a grid. And one thing is also, I settled on not drawing all the cables, because even though this looks like it doesn't have that many cables, actually most of the devices, like this one, actually not that one. Why not that one? Yeah, this one, for example, references the main scale, and the main scale is hanging out over in this corner, right? So that if I drew all the cables in the software, it would be cables just crossing the entire interface. So I came up with the rule, don't draw cables between systems, only draw the cables of internal systems. And yeah, I think it's the interface just, I think it evolved naturally as I was designing it, pretty much. I hope that answers. I got a bit sidetracked.
Yeah, I'm here. Thanks for awesome talk. It was kind of groovy, so thanks for that. As you mentioned, you're kind of iterating on this tool set, and how do you keep track of every like functionality and connections between all those variations and outcomes that tools produce? Another mini question, like if somebody will accompany you on this journey of creating sound, so for this project or in the future ones, what's your like learning part for this person to come up into this tool? Yeah, thank you.
I'm trying to precisely remember the question. It's I guess it's kind of, yeah, I've currently the software only exists for me, right? So I keep it all in my head, but then I use the code of the different modules as the reference. So if I ever forget precisely how a module works, I just go in and look at the code as a refresher. Of course, this would be completely unacceptable in a consumer product. One of the challenges, if I would want to bring this software to the public for everyone to use, I need to work together with a UI specialist who can really help me make this understandable and help me document it. This is in desperate need of documentation, and if anyone else than me is supposed to use it. But since it's just me right now, I just do whatever.
Amazing talk and performance. Just to piggyback on that, can we play around with this at some point?
The problem with the software is almost everything you do will result in the software just stopping. It has zero tolerance for, like let's say, for example, that let's go manual, for example, and let's find an instrument. That's this one, right? Yeah, this is a bip. Very nice. Just note that if I, in the instrument, let's say I go to -1 instead of 0, and I try to play it. Now it tries to play the note, and you see that it's just stopped. The software refuses to go any further because there was an error. Currently, because I always use it with a programmer debugger, the debugger actually tells me what went wrong. But this is a build, so it doesn't have any information about why it stopped. It just refuses. That's why it's very hard for anyone else than me to actually try the software, because almost everything you can do it just stops the software. But the crash itself, that I have no idea what happened. That actually has never happened on a different computer, so...
Okay, thank you very much.